Hello everyone. Good morning, dear authors and invited guests. Welcome to Technical Session 2A. Myself, Soumya Raut, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the Second World Conference of Information Systems for Business Management ISBM 2023, Bangkok, Thailand. The second edition of the conference is being organized in a hybrid mode. The physical event is organized in Bangkok, Thailand today, and the virtual event is being held through Zoom today and tomorrow, that is 7th and 8th of September 2023. This series is organized in extension to the ICT 4SD conference series. I hope you all will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 7 presentations. Please note, in this session, each presenter has been allocated 12 minutes for the presentation and Q&A. It means presenters should finish their presentation in 10 minutes and 2 minutes for Q&A. On 8 minutes, I will raise a gentle reminder for you all. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all with the chair of this session. So first, we are having Dr. Nirav H. Bhatt. Dr. Nirav H. Bhatt is Head Department of AI/ML, AMIST, Charotar University of Science and Technology, India. Experienced assistant professor with a demonstrated history of working in the information technology and services industry. He is skilled in SQL, cascading style sheets, that is CSS, Microsoft PowerPoint, data analysis, and C. Strong education professional with a master's degree focused in computer engineering from Dharmese Desai Institute of Technology. He has conducted expert talks and seminars at Big Data Analytics, IIIT Vadodara, NPTEL local chapter, and online courses IQAC cell at MSU Vadodara, NPTEL MOOC for Applied Science, PDPIAS Charosat. We welcome you, sir. I request you to say few words that can uplift the enthusiasm of all our presenters. Sir, are you there?
Soumya, Dr. Neerav will be joining us later in the session. Meanwhile, we can move forward.
Okay. Okay, ma'am. So next, we are having Dr. Sanjay Gaur. Dr. Sanjay Gaur is currently working as professor and head of Department of Computer Science and Engineering of Jaipur Engineering College and Research Center, Jaipur. He has published more than 95 research papers with Scopus Index and UGC recognized journals. Also published 8 books on computer science and information management, including Industry 4.0 AI and Data Science, published by Taylor and Francis Publications. He is a lifetime member of Computer Society of India and the Institute of Engineers. We welcome you, sir. Sir, I request to say a few words that can enlighten up the event.
Good morning, everyone. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Good morning, everyone. It's a great time once again to great time to spending time with colleagues and our community. And definitely, GR Foundation is doing tremendous work in the area of connecting new peoples and researchers and intellectual families. And definitely, this conference will be very good and one of the valuable assets for the participants who are joining here. And as per the theme of the conference is information system and business management. This is a great blend to running the whole economy of the world, business and plus information technology. It's need of the time to work with the information technology and manage your businesses, social media, other medias, and lot of technology, artificial intelligence, business data analysis, all are working in that direction. So I wish, I want to say best of luck to all participants. I think that they will provide us a good knowledge surface in the as per the norms of the conference events. So again, best of luck and welcome participants for your research papers. Thank you.
Thank you very much, sir. So now I would like to start with our presentations. So first, we are having Gandhi BNV with this paper, an integrated web-based and application programming interfaces for disease prediction through self-diagnosis. Sir, you can start with the presentation.
Thank you, Soumya, for warm welcome. And thank you, ISBM, for this opportunity to present my research paper and along with the other authors. I'm going to start explaining what about the research paper we have written about. So it's an integrated web-based application, which it is a real it is an so it is a application which we developed in our final year project, which mainly represents the need of a centralized system where all all the donors of it's a blood bank basically, where all the donors can connect from one another, so that can replace the underlying problem that in our society many people are not able to get our blood on a specified time. They need blood, but they are posting many things on Instagram. They are sending messages on Telegrams, but they are not getting blood at the right time. So there is a really need of a centralized system where transfer where we can list out the names of the people who are need in the blood and who can donate the blood. So the idea started from there of a web application for a blood bank. But then it later got developed where we saw the need that disease prediction was also coming there, because people are ready to donate their blood, but at the same time they don't know that what diseases do they have. And before knowing that what diseases do they have, we cannot proceed further for blood donation. So that's where the underlying situation of disease prediction also came into our mind. So we thought, why not to just uh, research more for the underlying problem and develop our project in a more different way. So at that point of time, we completed our project on the blood bank and pivoted ourselves to a machine learning model which will help disease prediction through self-diagnosis. So it's a kind of an API which we integrated to our application. So once the person who wants to donate his blood, he will just come to the portal, and once he will try to uh, input details of himself to him volunteer himself for blood donation, he will first have to self-diagnose himself for the diagnosis prediction API. So where there are many symptoms listed down before itself, so that the donor doesn't need to be specified about what he is going through. He can just click all the aspects, all the conditions he's having as of now, and then he can just predict what possible diseases he can have or he is having, so that he would just have a good idea about that he should donate blood or not. Even the core members of the organization who will just develop this pro software would also be able to analyze that the donors would are yeah, are efficient enough to donate the blood or not. So in this case, we will not only have a good amount of donors, we will have a, a, a pure amount of donors, that all the donors we have listed down are good donors and are not carried by any kind of disease or any types of viruses. So I would like to start with the paper, like how the paper is going through. I'll just create my sheet for the presentation. Shall I? Yeah. Just, there is some. technical problem. Yeah. Um, so my screen is my screen visible to?
Yes, visible.
Yes, sir.
Yeah.
It
Okay.
is.
So I'm the third author of the research paper. And the introduction coming to what I have all introduced as of now, the same problem that we got up with a problem, that blood bank system, and when we pivoted ourselves to an API where the disease where we have developed a machine learning model with various machine learning algorithms. So in order to predict diseases before even getting diagnosed. Though we are our research and our project is at the development stage. Yeah, we have completed it, though still due to the limitations we have, the accuracy is not 100%. And we always suggest, we have test and trialed it with various people, and we have always notified that it is only a software which is predicting and not a diagnosis app. So you need to get diagnosed after this also, and not be 100% sure of what it is predicting. So the problem statement, as it is the traditional prediction systems which we have right now, that nowadays there are many, say some predicting system like chat, some chat GPT kind of some predicting system using chat GPT-4, and they have some inefficiency in it. It's like many of the diseases are not covered in those areas, and some of the symptoms are also not listed down. So if I add something new, if I add a new symptom to that, the prediction may get wrong, because of the algorithms they have used, and because of the inefficiencies of their either of the less number of symptoms they have parameterized, or either the less number of diseases they have parameterized. So it may lead to wrong predictions, and at the same time potential complications. And at the same time, we lack a web-based UI system, an integrate an UI system where people can list them out themselves for diagnosis and for blood donation. Though we have some, I won't say no, there are none, but there are some websites, there are some portals, but they are not centralized. I want to develop a centralized blood bank system, so that everyone throughout the country or throughout the world could connect and list them out. So there should not there so it would help to just get to know all the possible donors and all the possible scenarios without any false alarms. So while the disease prediction API offer valuable insight of early disease to proactive disease management, still there is a need of further research enhanced for this accuracy and reliability. For that, we and other authors need more resources, and which we will gonna do in in future, which is our future targets. That we need some access to medical facilities, and we need access to some medical doctors in order to develop our software in a more though at the end of the day we are all software developers, and we are all computer science engineering students as of now. So we need medical assistance also. We once we get into a corporate world, we'll try to incorporate the project with some medical experts also, and develop our model into better way. So that's the problem. So coming to methodology, we have started with the blood-based system. So we have designed a interface using Node.js and HTML and all. And then we have the website contains handshake of to the donor and the recipient, where they can list themselves off. They will have to input their username. They will have to create a user by use address, blood type and all. And once we have created the website, we have created a backend using Node.js. And then the blood bank system has been developed where people can list themselves out. And then we pivoted out for the disease prediction. We try to research. We are tried to analyze many other algorithm, other products on the same, which are predicting diseases, and then we came up with some of the algorithm, like some of the technologies like naive Bayes and all, and we started to develop algorithms. It took us 6 months for developing an algorithm, and once we developed, we created a disease prediction API, and then we integrated the API through to the user interface using Flask. Then we tested out with using the testing data and training data, and then we actually manually real time tested it also by testing it out by providing the software to other students of our college too. And we got a fair good amount of results from that. So the result, coming to the result, in naive Bayes algorithm, we got an accuracy score of 83%. 83%. Using the random forest, we got up to like 92%. We using the decision tree, we got up to like 78%. And with the gradient boosting, we got a good remarkable score of 96%. So coming to we have used multiple technologies and we have used multiple algorithms, because each and every algorithm was very much into different coming to the type of parameters they are going to input. So in some cases we have diseases which in which the symptoms are very much not, we can't limit themselves into numbers like 0 1s 2s. We can't level them up. It is either yes or no. Symptom is either yes, either symptom is no. So coming to that, the same kind of disease can have a parameter in which the value is yes or no, that which is binary, and at the same time there could be a value which needs number, like fever. We need a number for the fever, 1 or 2 degree, 1 or 3 degree. So in that case, we need a continuous data. So continuous numbers. So in that scenario, we have what we have is like we have two different kind of what we can say two different kind of data. So in order to for the same disease, so we need multiple algorithms for the same to deal with the different type of data. Coming to the discussion, how a project gonna contribute in the field of disease prediction. Like a few months ago itself, we got to encounter a disease prediction model created by Apollo Pharmacy of in India, backed by Apollo Hospitals, and the API was really good. But the fact was they had very much lower number of symptoms. Like if I input a symptom which is not incorporated in their files, then it would the keyword then it would give then it would either won't be able to predict properly, or it will predict something which is not I'm having. So this prediction is a field where we uh, strongly need to input to research and work. So in order to create a really 100% sure diagnostic system, so that in India, for every time, almost in rural area, I'm talking about government hospitals, government doctors. For every 10,000 people, we have only 100 doctors. So so there is a huge load per doctor. So in order to reduce that, we need a model so that people can self-diagnose themselves at home itself. And if it's a disease is a small disease, they could just take medicines on their own and diagnose and just treat themselves. Yeah, and only those people who have who have diseases strong enough so that they need medical attention, like either it would be a typhoid or something like that, which need treatment, which is need to be admitted. The person need to be admitted. In that case, he or she could visit the doctor. In which in that case, the load on the doctor would be reduced. So the a need of such a disease prediction system is very much needed in a country like India and all over the world. And what are the limitations of the study? As being student of a final year, as final year students of a college, we were very much not allowed. We didn't had much data, demographic data on various diseases. As in India, the data on diseases is is regulated by central government, and one should not. And one outside the body, the outside our body means the hospital or government should doesn't know about the details of the patient. So we had very much limitation about the data, and though we wanted to incorporate various many types of diseases, but we had to come up with very handful of diseases. But in future we are strongly trying we are to research more on the topic, even study more on the technologies, and learn something more, and like studying masters in in this technology, and even trying to develop relations with some hospital or type with some doctors, and then get them on board and have a really and produce and develop a really better system than what we have. And at the same time, one of the limitation is even people have to uh, volunteer themselves, to like give their data. A lot, obviously they can be anonymous, their name should be anonymous,
I'm
but
sorry, sir, for
they
interrupting
should be
you.
keen of that they want to give out their higher data. So the conclusion that the same, we need this kind of system. And thank you so much. That was my time.
Okay, Nandip.
Yes.
Uh, so it was a good presentation, first of all, uh,
Thank you so much.
and you have done good work. But the thing is, when you have presented results, I just want to ask one thing.
Okay.
Have you analyzed that why gradient boosting giving you more accuracy compared to other models?
Uh, Sorry, Neeraj. Actually, Mashil, I am one of the third author of the research paper, and I was out of the gradient descent boosting. I'm really sorry that I have a very little knowledge about gradient boosting on this topic. Sorry, I'm really sorry about not delivering.
Okay. And what about the input data set that you've considered? Have you considered it from the standard source, or it was actually a real data, or it was a
It
synthetic data?
we tried to gather as much real data we could get. Like what we have tried, we have though the real time data was very small, as we are final year students, we have tried the best possible we could do. We have created Google Forms, and we have circulated through our classrooms and our colleges, and people have shared it with their friends also. So in that way, we have almost got 300 inputs from in 300 inputs. And but that was not good enough for developing a project like this. So we had to take data from database websites from various from other resources, and
Okay,
I'm
okay,
not
okay,
sure
got it.
that they are good enough or not.
Yeah, okay. So my future suggestions for the extension of this work is you just first study the characteristic of the models
Yeah.
and which one is the best suitable as per the characteristic of your data, and that will
Uh-huh.
give you the better result. As far as we are working with healthcare domain, we must be careful about the accuracy when we present or
Yeah,
train,
exactly, Nirav. That's
because
why I
otherwise
have,
it will.
yeah. That's why I have always said we have a disclaimer that it is just a prediction model, and not that when we have distributed the software for testing, no, or for giving out for the people to test. So that time we have cleared the disclaimer that it is only a prediction model, and not that you go by this 100% and get take medicines on the data.
Okay, thank you.
On this,
Okay, thank you.
yes,
Yeah.
Neeraj. Yeah, just Neeraj. Yeah.
Thank you, sir.
Uh, Thank you, Soumya.
So next we are having our next presenter, Pradnya Vishwas Chitrao, to present her paper on eco-friendly air conditioners, cool ants behave as a case study. Ma'am, you can present your screen. Pradnya ma'am, are you there? Ma'am, I guess she's not. So can we move forward with our next presenter?
Soumya, we can move forward to our next presenter.
Okay. So now I would like to call our next presenter with paper, B. Aishwarya, to present her paper on heart failure prediction for a patient using hybrid African buffalo optimization with NAF-based machine learning techniques. Ma'am, you can start with the presentation. Aishwarya ma'am, are you there?
I think, ma'am, we can start with the one who is present right now.
So, sir, can I move forward with our next presenter?
Yes, Soumya, please go ahead.
Okay. So next, I would like to call Paolo Tome to present his paper on information system field and analysis through a biometric methodology. So I'm so sorry if I have mispronounced your name. So you can please start with the presentation.
Okay. Are you listening? Yeah. Okay. I want to share my presentation. Okay. Okay. My paper is about the analysis of the information systems field when analyzed through a bibliometric methodology. Okay. This presentation agenda is I will do a brief introduction. I will talk a little also about the bibliometric analysis in information systems fields. Then I will show a proposed methodology, and the fourth point is the application to the different data sets, and finally I will do some conclusions and future works. Okay, the bibliometric methodologies are usually used to analyze the evolution of some fields, and they give helpful information about the evolution, the research priorities, and some aspects regarding to the allocation of scientific efforts. This paper presents a paper meta-analysis of the information systems fields. I do it in the period 2000 to 2022. It were now a large set of documents that we get from two different database. I get 18,000 996 documents from this database. Okay, regarding to other studies in this field about the information systems field, we can find several works in this domain. I summarize the main contributions of these studies, but in a global analysis, the works were more were reduced to a set of minor set of documents, and also are reduced to one journal or to a specific field of the information systems field. Regarding to the methodology, to the proposed methodology, we consider 5 main tasks. First, task for vocabulary definition. This task is responsible for get a list of terms that are usually used in the information system domain. The second task that we consider is the definition of a dictionary, because this dictionary will be helpful for consider equivalent terms that usually are applied, and for that purpose, the accuracy of the relevation is determined for in most of the situations by the dictionary definition. Third task is the search process. The search process is responsible for collecting the documents from the database. After the collecting of documents, we implement the task for text mining. This text mining is responsible for getting the most relevant terms in the process. And the last task is the analysis of the results. Okay, in the analysis of the results, we consider the relevance of each term and the evolution through the years of the relevance of the term. Okay, for that purpose, we develop a Python software application, and we base the software application on some concepts that are very relevant for that purpose. We consider the one model for one ontology editor. This ontology editor is very important for define the vocabulary and also the query for the search process. Okay, our software application in this article communicated with Web of Science and OpenAir, and the communication is done first by putting a search string that I use the two terms which were information system and information systems. Okay, from the search process, we get, as I said, a large set of documents. Okay, and these documents were retrieved in JSON format. Okay, here you can see the amount of documents in each year that I retrieved, and I announce them later. Okay, regarding to the main terms that I retrieve, I show in this graphic the analysis of the 21st positions for each year. Okay, I put some arrows to emphasize the relevance of some of the terms, and as you can see, the terms computer science, data, decision support, design, development, human computer, information retrieval, integration, modeling, ontology, performance, social science, science and software have a great level of relevance. Okay, they appear in the top of the 21st positions in the rank. Okay, but now analyzing some of these most relevant terms through the years, some of them, for instance, computer science, data, information
Sorry, sir, for
retrieval.
interrupting you, but you are having 2 minutes. Can you please conclude your presentation?
Okay. Are always in the top. Otherwise, for instance, ontology, it was in the top some of the years, but in the last 7 years, they slowed down, and the term slowed down, the relevance of the term slowed down, and is not very good. Okay, conclusion and future works. The nows, as I previously mentioned, the relevance between the period 2000 to 2022. There are set of terms such as computer science, data information retrieval and modeling with a great relevance. The new evolution of the work is do the cross-reference between documents and the impact. For instance, the impact measured in terms of number of relevance of each publication. Okay, the list of the reference that I used in this presentation. And thank you. I answer to any question if you have questions.
Thank you, sir. I request our session chair to kindly come up with some questions.
I don't think there is a question. It's a good presentation. Only one thing is you are not mentioning any specific algorithm in methodology algorithm which you utilize in this paper.
Sorry, I cannot
Any
understand what
specific algorithm you utilize in this research work?
what I utilized
Specific
for what?
algorithm.
For retrieving information.
Yeah.
Okay, I have retrieved information, as I said, from Web of Science through the platform. Okay, and I get the information in JSON format. Okay, the relevance of the concepts. I use the TF, EDF, IDF technique.
IDF technique.
Yes, sir.
Can you explain in 1 or 2 line IDF technique?
The technique is applied to the title, abstract, and keywords, and measures the relevance of the word in this body of in the text. Okay, the frequency of use of the term is used is considered by the technique.
Okay, fine from my side. Okay.
Okay,
So, madam, you can proceed further.
Thank you so much, sir. Now, I would like to call our next presenter, Juan Mendoza, to present his paper on Porebo Digital Intermediation Platform based on blockchain for the management of police records. And sir, you can start with the presentation, please.
Okay. Hello, everyone. Thank you for being here. Today, I will talk about digital Poribo, digital information platform based on blockchain for the management of police records. First, we talk about the issues. In today's technology advanced world, many business and government entities still rely heavily on physical documentation as an essential part of their admission process and various other activities. For this kind of documentation, the shortcomings and inefficiencies in valid information, signatures, and vouchers highlights a common problem, the documentation falsification. In the case of Latin American countries, a significant number of politicians have been found presenting falsified criminal records, taxes documents, and even temporary certificates. This reveals the vulnerabilities in the current documentation system and the inadequate validation methods paying them. In the case, in the last 3 years, there was a triple increase in case of proceeds for forged documents. This information we get about the annual report of police records by the National Police in Peru. So we talk about the core. Regarding the technologies we propose as a part of development for the solution to the issue of falsifying police record documents, first, we base our architecture on a blockchain network through Ethereum. So with this platform, we can use the tools of a smart contract. With the smart contracts, we ensure the creation of the police record document and the responsibility authors of the information. In terms of content, the information to be registered is presented to the user in a PDF format. However, for a process in the blockchain network, we convert the file into a blob format. This allows us for seamless entry into the block without any issues or tampering with the content. For the validation of the involved parties, we are implementing digital signature models as a means of identity. This validates both the person registration document and the one who requires. Lastly, and equally important, we use a timestamp feature that allows us to know and certify the creation time of the document validation exists. So, about the procedure, first the user make a query of all incident-related documents regarding the requesting user. The next stage involves the creation of a PDF document, which is provided to the requesting users, detailing all the incidents associated with their name and their identity number. The next step is these files in a PDF format we give to the user, and then we make a computation process to the blob type. This makes us facilitating in registration with Ethereum blocks. Once this file conversion is complete, a smart contract is generated where the responsibility for the content validation and ensuring the creation criteria are met. With this initial contract, personal information of the requester, as well as the user in charge of the query, is included. In the next step, we generate a timestamp that confirms the date and time of both documents creation and is associated with a smart contract. With this last contract, we validate the time and the user who entered the request, thereby ensuring accountability in the query and registration process. Finally, all the content is uploaded to the blockchain network and then established contracts are set in place. In this case, we are using all the services of Amazon Web Services in 4 models. The first model is about the front end, which is connected with the API. We use the technology of Next.js, and the endpoint with the front end made by Angular framework. About the expert judgment, we validate with different experts in architecture, software, and design, and we have these results. 85% of the experts give us a very satisfying results about the relationship between the police record documents and blockchain technologies, along with different information techniques and using the layered design of the architecture. Also, we get a good view about the security measures for a failover scenario. And for the last, the 80% of experts express their approval of the architect design related to the smart contract. you have any questions, we'll listen.
Mundan, no question from my side, but did you implement it practically? Hello,
Yes, we
Mr. Mendes,
implement.
did you implement it in practical manner?
Yes, we implemented in the school laboratory. First, we all implement all the backend and APIs. We receive the
Yeah.
information, or we create a block to use in the blockchain.
Are you find satisfying the results from this technology?
Sorry, can you repeat, please?
Are you find satisfying result after implementation of this technology?
Well, the result we have are very sorry. The result we have the implementations are very satisfactory. We have 98% of the good registration in the blockchain. We use in case we use the blockchain Ethereum in a developer way.
Okay, fine, good. Thank you.
Have you
Good.
considered any security related part in the blockchain?
In this case, we are using the service of VPN. So we are in the first layer, we are using a security network connecting the blockchain, and also it's a private blockchain network. We use a template giving us Amazon Web Service. Thank you very much.
Thank you so much, sir. Now, I would like to call our next presenter, Kanika Vidange, to present his paper on synchronizing business inspirations, a conceptualized computational approach. Sir, you may please start your presentation.
Thank you. Can I get the screen sharing permission?
So, yes, you
Okay,
have.
right. Okay, right, thanks.
Sir, are you there?
Hello, I'm sorry. I had a small power interruption. I think now I'm audible, right?
Yes, sir, you are audible.
Okay, sorry about that. So let me quickly continue. So this is my topic. So synchronizing business inspirations, a conceptualized computational approach. Now, actually, now the main important point is any organization is having business inspirations. What do you mean by business inspirations? Vision, mission, objectives, goals, and sub goals. And also, these organizations are having business processes. However, if there is a asynchrony, right? If the business inspirations and the processes are not properly matching, organizations will not be able to reach to their target, because time to time political environment, business environment, atmospheres are changing, and therefore the business landscapes of the organizations are also changing. So sometimes the business inspiration section is getting updated. However, maybe the processes are not getting updated accordingly, or vice versa. So this causes a huge issue. It's like you are taking a wrong medication for the wrong disease, right? So moving forward, now, as I mentioned earlier, asynchrony between the business inspiration and the processors is going to be a huge issue, right? And it might lead to lesser profits, and sometimes in the severe cases, even the organization might lead to bankruptcy as well. So in this research, actually, we are looking at how the synchrony between business inspiration and the business processes can be computationally evaluated. We are planning to provide a sort of a numerical and a color-based notification to the stakeholders, just to be aware about how much the process is matching across with the organizational inspirations. That means with the vision, mission, and the objective related perspectives. Now, we look into the literatures as well, and there were ample of examples that we came across about business failures due to this asynchrony, right? One such good example is Fiat's failure in Asian market. It was doing really well in the foreign market, and they applied the same processes, same strategies in the Asian market, but it failed because the proper adjustment did not take place. Likewise, there are lots of examples that we came across. So that clearly emphasized that there is a huge issue that has to be addressed. So henceforth we look into the technical implementations and the technical remedies that we can provide to overcome this problem. And however, we were not able to find a complete application or a solution or an algorithm that is available for the purpose of matching this synchrony. However, we came across some very interesting tools, technologies that can be utilized for such purposes, such as business motivation modeling, then BPMN, Chaos, and SAIF, Sackman framework. Likewise, we came across some conceptual theories that could be utilized for this purpose in an effective manner. So the research methodology actually we attempted to follow in this designing is actually the design science research methodology. So initially we have a good understanding about the problems, and we had several discussions with consultants, business consultants, ERP consultants. Then we get together development software engineers and research students, and we are planning to come up with a system and go for the evaluation and conclusion, and it might iterate until we get the satisfactory results. So this is the proposed architecture. Actually, we are planning, because this is a complex procedure, matching the synchrony between the business processes and the business inspiration. It's a complex thing. Therefore, we cannot do it at a one shot. Hence, it is suggested to go with a divide and conquer approach. For that purpose, we have identified better to use an instructional ontology, like an upper ontology. So we have identified and we are planning to give the name for that ontology as beta ontology. Beta in the sense, it's actually a concept used in ICT industry, business IT alignment. So in this ontology, to the endpoints, we are planning to link some other ontologies and frameworks which are designated with different tasks associated with this synchrony matching, because it's a complex procedure. Now, in these papers, actually, our focus is only towards this business inspiration framework, because this is a large project which is under the development now. Now, if I elaborate how this business inspiration procedure is planned, so it's like we have initially a sort of an interface like a wizard. So and it is prompting some structured questions, maybe asking the user to enter the vision, mission, and the objectives, and the goals and the sub goals. Likewise, then captured the responses will be stored in the relevant placeholders of the ontology that we have designed. Afterwards, we are planning to go with fuzzy inferencing and similarity assessment. And also, we are planning to integrate context and content-based assignment, because context is also a very important aspect that we have to consider, because depending on the context, sometimes the interpretations might be different. And finally, we are planning to provide some updation about the real-time synchrony about these segments using a numerical value and a color-based notification in our HCI. Now, this is the designed algorithm. So if I quickly take you through this, so initially we are entering the business inspiration, these sections, through the guided wizard. Then initially we have a NLP section. So we are removing the stop words, prepositions, models, punctuations likewise. And then we are actually extracting the opinionated terms. We refer it as the opinionated terms. Henceforth, it is decided to use this CNC algorithm that has been highly cited, and it's been developed by a scientist called Vranzi. So it is being used for the contextual similarity assessment. because I mentioned that depending on the context, interpretations might be different. So we have provided some adjustments to this algorithm. So initially we are going to do post tagging, and also we are in our interface, we are providing some regex rules in a customizable banner, because then we can adjust it to suit out to our domain, right? Because the domain might be different from business to business. Then we are extracting the opinionated terms after the NLP cycle. Then we are deriving the context relevancy figures, which is denoted by this NC figure. Then, depending on this context relevancy figure, we are sorting them in the descending manner. So the top consent relevancy items will be available at the top, and the values which are having a very minimal figure will be available at the bottom. And we are truncating the last 25% because we identify it as no relevancy. Then the next step is thematic similarity analysis, right? Then the topic wise, thematically how these things are related. So initially we analyze contextually how they are related. Then we are analyzing thematically how they are related. So we are going to use latent semantic indexing algorithm for this purpose. And without stopping from that point, we are going to semantically also analyze, right? Because sometimes there might be synonyms might have been used. So we might have to use word sense disambiguation. So therefore, we have coupled a LESC algorithm with WordNet and ConceptNet just to extract the proper meaning of the relevant segments. So here we have used three measures: contextually assessing, thematically assessing, and semantically assessing. Then all these numerical figures associated with these similarity values, we are going to log them in a lookup table, separate lookup table that are being created for vision, mission, goals, and the relevant sections of the business inspirations. And eventually, we are going to do entropy calculation, right? Entropy and information gain calculation. So depending on that, we can see how much the relevant topics are synchronizing with each other and matching with each other. And also, we are going to perform fuzzy inferencing, because I mentioned earlier, here you can see there are multiple sections available in this process. So currently, we are focusing only the business inspiration framework. So we have to see how outcome of this is connected and affecting with the other sections as well, right? Therefore, we are performing fuzzy inferencing. And finally, we are planning to derive the percentile values and color-coded alerts to inform the stakeholders. And this is the schematic structure we have proposed for the business inspiration components, where the vision, goals, mission, and sub-goals have been connected. So this arrangement will be used for the reasoning structure with the SWRL rules, semantic web rules. So to be frank, actually the development of this still not completed. We have started the development, and development is ongoing. So we are in the process of developing actually ontologies with the Protege, with the OWL, and those ontologies are connected with the its fuzzy formats with another plugin for the fuzzy inferencing. And we are using some other LESC, and we are testing on the Jaccard coefficient as well currently for the similarity assessment. Finally, we are planning to provide color and percentile values. And conclusion is actually, as I mentioned, a lot of organizations lead to bankruptcy because they are not considering about this synchrony as an important fact. But ultimately, they will realize when the business is decreasing, when they are executing it some time back, but then it might be late. So here, during a roundtable discussion, if the people are discussing and brainstorming at the same time, immediately you can get the impact, how much your processes are relevant with your business inspirations. So that will help to come up with proper business strategies. So that is the high-level idea. And thank you very much for listening.
Hello. Hello.
Hello, yes.
Yeah. The literature study that you presented, I mean, your work is good. You've
Yes.
presented it well.
Yes.
But the
Thank you.
literature study that you presented is very old paper, might be referred and
Yeah.
analyzed.
Yes.
So maybe the recent work has been carried out in the same area or the related area.
Mhm.
You should have to refer
Yes.
that. And
Mhm.
one more concern is regarding why to choose only LSI. Any specific reason for latent semantic indexing technique? There are many other recent indexing techniques people are using. If you refer
Yes.
to the recent work. But if you have any specific
Yes.
reason to use that only in your work, then you may explore.
Yes, sir. Right. So we will actually still, this is not a completed research. We are experimenting on different pathways. So currently, initial version has been developed and it is giving some reasonable results. That's why I have mentioned that even we are with the LESC algorithm, we are comparing with the Jaccard coefficient as well. So thank you very much for your suggestion, sir. We will consider on that as well.
Oh, yeah. Yes. So Soumya ma'am, we can go ahead with the next.
Thank you so much,
Okay,
sir.
thank you very much. Thank you.
Now, I would like to call our last presenter of the session, and after that, we will move forward with the remaining one. So, I would like to call Kesai Dhanush with his presentation on Tesla Twitter merger, a revolution in business through social media networks. Sir, you can start with the presentation.
Yeah, sure. Mm, yeah, I think my screen is visible, right?
Yes, yes,
Yes,
it is
sir.
Yeah,
visible.
yeah, sure. Yeah, okay. Thank you. Hi everyone. Today I'm here to present my paper, Tesla Twitter Merger: A Revolution in Business Through Social Networks. Firstly, I would like to thank the team ISBM for accepting our paper, and I hope this paper will be a valuable one for the upcoming researchers who are trying to explore this area of research. Yeah. Today's agenda is like I've divided it into 6 parts, mainly introduction, literature review, history of Twitter and Tesla, advancements of Twitter and Tesla, revenue generation, and I've summarized all these points in the last slide. So, introduction. We all knew that the Twitter's acquisition has created a stir among the media circles, like the moment Elon Musk came forward to buy out the Twitter, and the deal was stalled at some point, and also again he finally closed the deal. So we have discussed all these points in our paper, and we have structured all the content right from the history of these companies, the revenue generation methods that are being used by the company, and also the revenue generations, like the annual revenue over the last few years. So, starting from the introduction, so Musk acquired Twitter on April 14. That was his first call to acquire Twitter, but it went on till October 27, the day where he finally took over the Twitter within the 6 weeks from October 27. So, uh, despite a poison pill defense, his 44 billion acquisition offer gained unanimous approval on April 25th. Musk's vision included new features, open source algorithms, spam bot measures, and commitment to free speech. And it came with a few challenges. Like the legal battles followed Musk's announcement to terminate the agreement due to spam bot handling. And Musk's reversal reaffirmed the acquisitions finalized on October 27. He became Twitter's CEO. His leadership led to senior executive changes, staff reductions, and Twitter's transformation into a private entity merging with X Corp. literature review. These are few of the papers which we have referred for before writing this paper. And as you can see in the first point, Isha Gupta in her paper states that mergers have a beneficial impact on the value of acquiring firms after the merger, and previous synergies have a favorable influence on future synergies. And Salim Ahmad, in his paper, mentioned that mergers and acquisitions can result in legal battles and structural changes, new management, and policy formation. However, they can also lead to growth, increased shareholder revenue, and higher revenue through resource consolidation, like the one which are seeing right now. We have seen a lot of changes in the Twitter's management body, right? The CEO has been changed, and the legal advisor committee has been changed. And these are the things which are stated in that paper. And Edward Peter, in their paper, stated that Tesla has shown a startup that can enter. It is such. It has proved that a startup can enter and disrupt the markets in of the in some established countries. So, coming to the history of Twitter and Tesla, Twitter was founded in 2004 by Evan Williams, Bill Stone, and Noah Glass. Initially, it was proposed by Glass, and the first tweet was sent by Dorsey on March 21st, 2006. Uh, like any other social media, it is similar to the Facebook. Like even the Facebook launched without a no clear revenue system. So similarly, it began as a free SMS-based social network. It has introduced promoted features for revenue in 2010. That is the year where Twitter began its revenue generation, and it has achieved some good milestones. It has seen a rapid growth, like 65 million daily tweets by the year 2010, and new Twitter redesign. That UI has completely changed from 2010 with the multimedia option, like you can view the videos in the Twitter as well. And recently in 2021, a new feature called social voice feature, also known as Spaces, is released to the public version. And it also faced recent challenges, like in June 2021, Twitter has deleted the country's president tweets. So it has to uh, it has a challenge, like it was banned in Nigeria. And also it recently settled a lawsuit in May 2022, paying $150 million to the US Department of Justice and FTC with privacy audits. And evolution of Tesla, it disrupted the electrical vehicle industry market, focusing on innovation and scaling. It was founded in 2003 by Eberhard and Tarpenning as Tesla Motors Incorporation, diversified into clean energy equipment and electrical vehicles. Its first mobile vehicle, called the Roadster, was introduced in 2006, and the very well-known Model S is introduced in 2012, and the Model X in 2015. It acquired a company called Solar City in 2016, forming Tesla Energy, and it expanded its gigafactories in Shanghai, Germany, and Texas. Launched, it recently launched Model Y in 2020 and achieved SP500 inclusion, surpassed the combined market cap of major automakers in 2021. And currently in the US, Tesla holds the major market share of EV industry, and it is ranked number one among its competitors. And it has achieved key milestones, like it integrated EVs, battery storage, and solar power, and also uh, made strategic acquisitions for battery technology and automatic automation expertise. And Giga Berlin facility announcement solidified Tesla's global automotive influence. And advancements of Twitter and Tesla. In March 2006, the first tweet, "Just set up my Twitter," marks the Twitter's creation. It was sent out by Jack Dorsey, who is also co-founder of Twitter. And in April 2010, promoted tweets introduced advertising, the one which I mentioned earlier. That is the point where the Twitter began its revenue generation journey. And in 2015, group direct messages and Google partnership. It partnered with Google, uh, and and it is a strategic kind of partnership. And in 2017, the character limit expanded to 280. And in 2020, fleets inspired by stories were introduced, like the features which we see in Instagram. Similarly, a feature called fleets was introduced by the Twitter team. And 2021, spaces, live audio conversations, foster interactive experiences, etc. And in 2016, algorithm timeline sparks debates over echo chambers, and also s- the spaces enhances the user experiences, aiming to engage through live audio. Similarly, we have seen a lot of advancements in Tesla as well. And initially, customers received Tesla Model S from Fremont factory from in the date June 2022 2012, and Model X SUV production starts after a year's delay. And Tesla announces acquisition of Solar City met with skepticism. Model 3 delivers begin for employees with over 500,000 pre-orders. And Tesla has secured a contract with China for Shanghai automobile assembly plant. And also, Musk stunts by announcing plans to produce 500 vehicles by 2018 and 1 million by 2020. And these are the primary sources of revenue generation of Twitter and Tesla. The major revenue sources of Twitter are advertising and data licensing. Advertising, mainstream revenue, and data licensing is their additional income source. In 2021, 4,505 million from advertising services and 571.79 million from data licensing are the revenue figures for the year 2021. And the and coming to the Tesla's revenue, the research and development, the breakthroughs through Tesla's global sustainability efforts, and majority of the revenue from the EV sector, 5% from energy storage and batteries. And by 2021, the net income surged by 665.5%, and 2021 revenue reached 52,358 million across the divisions. It is equal to like $52.3 billion. I would like to conclude that Twitter is one of the most used social networking platform with the world's more eminent people active in it. And Tesla is a leader in developing emerging technologies like electric vehicles and green energy. Social networking plays a key role in changing in technology, and it's bringing the awareness to the public. So since technology and social networking are mutually exclusive, the business progress also should be aligned with it, which makes Tesla acquire Twitter. This merger makes the progression of technology drift at a rapid pace. So in the future, we might see that Musk might be using the Twitter to as a kind of marketing strategies for his own companies like SpaceX and Tesla. And also we know that he has been using Twitter for a while to improve the cryptocurrency markets and stabilize the cryptocurrency markets. So we might see Trump Musk using Twitter for his marketing strategies. Thank you.
Thank you so much, sir. I would request our session chair to
Hello?
come with the question if they have.
Yeah.
So, what is basically your conclusion from this study?
We would like
In a
to
two-line,
conclude
how
that.
can you conclude your entire study, whatever you've done regarding this merger?
Yeah, like the merger the merger will play a key role in the coming days. Like since the technology and the social network are mutually exclusive, I think that uh, they it will like we could see the benefits of it when since social media can play a big role in bringing technology and creating awareness to the public. So I think that this makes the progression of technology drift at a rapid pace.
So, have you analyzed or observed any negative part of it? Same social media, but now what are the side effects or let's say the negative
Yeah,
part of That
Yeah,
that must
sure.
be studied, when
Yeah,
such kind of movement
yes.
started.
Because the one example is that Musk has been using the Twitter for his own beneficial, for his own sake. Like we all know, he owns the majority of the Doge cryptocurrency. So whenever the moment he, just tweets about the Dogecoin, the suddenly the price of the Dogecoin increases rapidly. Lo, it is a kind of misuse with the Twitter. So that is some some people raised concerns when the news came out first that Musk is buying the Twitter. So people have raised concern that he might use it for his own sake, so he might misuse it. So yes, this merger comes with a disadvantage. So
Okay, got it.
yeah, okay.
Thank you so much, sir. I want to raise a call for Pradnya ma'am. Are you here? Okay. So next, I would like to call our next presenter, Aishwarya ma'am. Are you there?
Yes, ma'am. I'm here.
Okay, ma'am. So I would like to call you to present your paper on heart failure prediction for a patient using hybrid African buffalo optimization with NAIF base.
Yeah, good morning, everyone. My topic is heart failure prediction for patients using hybrid African buffalo optimization with these these are the contents followed by abstract interaction with which review, system design, and algorithm, result and discussion, conclusion, and reference. So, coming to the abstract, we have declared the heart failure as an epidemic disease 25 years ago. The primary cause of this particular disease is the imbalance in the mitochondrial oxidative capacity. That is something that how far our body is able to absorb the oxygen. In this study, we have used the Gary data set to improve the accuracy of the heart failure prediction. So we have done a hybrid approach here using African buffalo optimization with various algorithms to forecast the prediction of the heart failure for a particular patient. So this work helps us to improve the forecasting of the heart failure, and we've done a comparison with a few algorithms which I have done in the report. So this particular model can be integrated with any medical information system, whether the heart failure or any other particular disease with pertaining to location with the real-time. And coming to the introduction, the heart disease is becoming more commonly day by day. That is 25% of the patients die suddenly with no follow-up symptoms of any heart, what do you say, the heart disease parameter. So among the leading causes of death is the heart failure, and it is one of the common diseases for an elderly and middle-aged people. As we know, this heart disease is particularly a dangerous disease that causes severe illness, and it also leads to death in the early age itself. So we have an extensive study with machine learning to provide alternatives to such as clinical diagnosis, because many of us have poor lifestyle, unhealthy consumption of food leads to heart disease, and it has gradually become a global public health. So doctors and hospitals are currently having difficulty in predicting this particular disease and how to diagnose it in the human. So computing technologies advancements, whatever we have in healthcare facilities to collect the data and it gets stored in the system for decision making. So in developed countries, many hospitals collect these data and store the patient data in digital and manageable format, and this is known as public health records. So these are all the causes of heart failure, as I told before: diabetes, high blood pressure, obesity, and involved heart disease, and any other health-related problems. So in my literature review, I've just taken a base paper here. So in 2021, we do demonstrated an analysis, and we developed a monitoring system for the prediction of the hard disk using Cleveland hard data set. We utilize a test called the fold-out test with SBM algorithm achieving an accuracy of 88.3%, and we use the best fit selection algorithm to choose the top 7 features available. And the next paper it was in 2020 was the number that we used the new algorithm and she implemented it in the data tool, and we had an accuracy of 86.41%. The next paper it was in the year 2019, and he suggested many data mining approaches, and he focused on developing the machine learning method for detecting heart patients in diabetic patients. Our system design goes like this. First, the user interface, next is algorithm, core and output interface, and reverse visualization. So in the user interface, we left to the user or any individual to optimize that particular interface with minimum programming language. So it provides options for the user to input only specific parameters or any optimization function that is needed for the prediction or classification. And coming to the next step, this particular algorithm is the main algorithm which is used in the prediction of hard disk. So the functionality of buffalo algorithm is nothing but first we initialize the buffalo and updating the position by calculating the thickness function. After calculating the thickness function, the lead buffalo will be moved and we will be giving the position to the leader buffalo. So in the output interface, we display the information with respect to optimization process, including how many iterations it has gone and the best solution so far, whatever we got, and we offer the option to save the result and log or maintain for later analysis. And coming to the visualization part, many visualization representation are developed with respect to optimization process such as convergence plots, thickness landscapes, and buffalo movements are also maintained here. So visualization basically helps any user to understand how this algorithm is performing and make some decisions based on that. This is how our system is performing. First, the data is collected, then cleaning and pre-processing is done, and we train the model and we classify the particular data set where the patient is with heart disease or without heart disease. So this is how the African buffalo algorithm works. So randomly we choose the buffalo position and we evaluate the fitness valuation for each and every buffalo. First we pick a global buffalo and it is represented as BG max, and we just keep the best buffalo location as BG max. Once calculated, we update the individual buffalo according to the equation and judge whether the BG max is updated. If yes, we just proceed with step 5, otherwise we just randomly again choose another buffalo position, and if it goes, if it is the best solution, we just terminate the picture. Coming to results and discussion, the accuracy of the proposed system compared to the existing model. Our algorithm has 83.64% compared to decision tree density algorithm of linear regression. The same thing is presented in the form of a graph. And coming to the sensitivity, it is 86.70% compared to the decision tree, genetic algorithm, and linear regression. Our hybrid African buffalo performs very well. And the time consumption for executing this particular system is 0.73, which is very less compared to the previous algorithms, which is done by the. And coming to the X4, our algorithm has 0.894, and it is also high when compared to the other model. So coming to the conclusion, the result of the African buffalo optimization with null base, because regression trees and other algorithms which is compared here often lead us to a single solution. So sometimes it can miss the mark what we want to achieve. And we have used before evolution methods here like accuracy, sensitivity, transcription, export, and certain kind of charts to detect it in the visualization format. And thus our proposed system, ABA plus base machine learning technique outperforms with our sample data set in terms of hard disease prediction, while other existing systems perform poorly in terms of predicting the heart failure. And these are my references. Thank you. Hello.
Yeah, thank you so much, ma'am. I request our session chair to come up with some question if they have.
Sorry to interrupt, but can I ask the question?
Yes, ma'am.
Hello.
Yes, ma'am. Hello.
So my question is, this approach is applicable to multi-class problem as well?
Yes, ma'am. We can just extend this to multiple problem.
And in new base, which kernel you have used?
Ma'am, can you repeat the question?
My question is, for new base, which kernel you have used? Like either Gaussian or multinomial or Bernoulli for probability?
Not sure.
New base has basically two things, either 0, 1 with the maximum probability, right? So
Yeah.
for that, you need to use some probability distribution.
Yes, ma'am.
So which probability distribution you have used for implementation?
I have used Quotient probability.
Sorry, your voice is very low.
Hello. Hello.
Yes,
Can you hear me now? Quotient probability.
posterior probability, but next to that I was asking. Okay. And one more question is, like you mentioned about African buffalo optimization. So at a time, how many values you are updating? Like it is
I'm
a
just
herd of buffalo.
calculating the I'm just taking the best buffalo position one and calculating the fitness function particularly for each and every buffalo. And if a buffalo is getting the best count, I'm just replacing the target buffalo which I have fixed. So like this is giving me the best solution that is calculated to fitness function. So I
At
keep on
a time,
updating.
how many
Update
parameters
only
value
one
your
leader buffalo only they are updating. Only one.
only one value
Yeah.
of what?
BG max.
Sorry?
BG max, ma'am. BG max is the variable which we are
VG
for
max.
master
VG
leader
max
buffalo.
is in NB is what that I'm asking. VG max I understood from buffalo optimization, but
Yeah.
that refers to what in NB?
This parameter.
Hello?
Hello. The best solution, ma'am.
Best solution. Okay. Thank you.
Thank you, ma'am. I request our session chair to ask some question if they have.
So, madam, no questions from my side. You can proceed session at next level.
Okay. Okay, ma'am. Thank you so much, ma'am.
Thank you, ma'am. Thank you.
So, I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was very much informative. We, on behalf of the whole team, thank you for the support during this second version and the previous first version of the conference. We will be happy to have you in the third version in 2024. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publications will be live within 6 months. Kindly cooperate with the team of ISBM 2023. I also thank our session chairs, Dr. Sanjay Gaur, Dr. Neerav H. Bhatt, sir, for chairing the session. A token of appreciation to the chair on behalf of Team ISBM 2023 and Global Knowledge Research Foundation and partners. I also request our session chairs to enlighten me as well as our hardworking presenters with their beautiful words. Sir, please.
Okay, Soumya madam. All the participants presented in very good manner. Gandeep, Aishwarya, Palo, Mendoza, and Kartika and Said. All the papers are very good and papers are valuable. Sometimes the technical details are missing in the papers. So my suggestion is at the next time when you are presenting paper somewhere, try to focus on research methodology and your experimental work more, algorithm more. Uh, it is actually the peoples are here to listen and here to share the technology in transmission. So I feel that there is little bit lacking that we are not exploring the actual experimental work. So my suggestion to participants, please explore your experimental work, either it is algorithms, coding, or process also. It will be beneficial for others. Anyway, all the sessions and participants are very good, very nice. Congratulations from my side, be a part of ISBM. Thank you everyone.
Thank you, sir. Neerav, sir, can you please say some words?
I think I'm agree with the Sanjay sir. Whatever he said is. Add on to that, I just want to add one more thing is the presentation time which is given to them is 10 minutes. So somehow they have to manage their presentation. It is also one of the skill that you can present your own work within a 10 minutes, where you emphasize on the important part and you complete on time, so that question answer time can be utilized properly. Apart from that, whatever Sanjay sir said is absolutely, I think, correct. And yes, there are wonderful presentation and the work. We also come to know so many other things, new things. So thank you for this opportunity and good luck to all the participants.
Thank you, sir. I request all the presenters as well as our session chairs to kindly turn on their video camera so that I can take a quick snapshot. Thank you everyone for a valuable time.
Thank you so much, everyone. Stay safe and take care.
Thank you.